So we're going to be solving quadratic inequalities today. I'm going to start doing it algebraically because some people are getting real confused with the graphic part. So we're going to start doing them algebraically. This is not like it's not a function, all right? We're solving an inequality. So if you think back to, I don't remember, middle school or something, when you had something that looks like this and you had to solve, right? And you minus 1 and you had 2x equals 2 or less than 2. Right? Divided by 2. X is less than 1.
It's still not 2.
Well, no, it's not.
And then you draw your number line. And it's an open circle. And x is less than. So we're going to use the values that are less than 1. Do y'all remember doing that?
Yes.
I used to get lost.
Oh, because you draw the arrow, like if you draw the arrow in a little greater or less than sign, then you bring it over.
Alright. That's what we're doing today, but we're doing quadratics. Alright, so we're putting in quadratics here. So, number 5. Because it's a quadratic, you want to move everything to one side. So we're going to add 5 to both sides. X squared plus 6x plus 5 less than 0.
We start over there.
Mm-hmm. Alright, so make it equal 0. That's your first step. Equal 0. And now we need to find my solutions. So I'm going to factor this. What two numbers multiply to give you 5, add to give you 6?
3, 2.
1 and 5.
1 and 5.
On tripping.
X plus 1. X plus 5. You set them equal to 0 and you're going to solve for your x's. What are your two x's? Negative 1 and negative 5. Are we all good with me skipping this step?
No.
Yes.
Okay.
No, I'm going to do that step all the time.
Yeah. Alright, so I have my two solutions. I'm going to put them on my number line now. Which number is going to go first? Negative 5, because it's smaller, right? Negative 5, negative 1. I don't care if you fill in the other numbers. I just need my two solutions on there. Okay, so if you want to fill in the numbers, if that makes you feel better, you can. I don't need them, though. Alright, what's up?
Does it matter where we put the numbers on my line?
I mean, the smaller one needs to go first.
Oh, yeah.
But other than that, no.
I counted like lines by word.
Oh, yeah, I don't care. The lines, I don't care. Just just make sure the small one goes first.
It's because the teachers wanted everybody to put everything on there.
It's too much.
Put every number on.
Yeah, extra.
Yeah, it is. It's way extra. Alright, so open circle or closed circle?
Open.
How do you know it's open?
Because there's no line.
Because there's no line.
Very good. So no line under the inequality, which means it's going to be an open circle. So because there's no line, it's open. Okay, and now I need to figure out where my arrows go. Because of the quadratic, the arrows get kind of tricky. So we're just going to use a test point. Your arrows either going to go out or they're going to go in. All right, so that's your two options. What is going to be the easiest number to test?
0.
0. Where is 0 on my number line?
Right in the middle.
In front of the negative 1. So 0 is like right here. So I'm going to use 0 and I'm going to plug it in. I'm going to test it. So 0 squared plus 6 times 0 less than negative 5. What is 0 squared?
0.
What's 6 times 0?
0.
Okay, so I have 0 plus 0. What is 0 plus 0?
0.
Is 0 less than negative 5?
No.
No. So 0 doesn't work, right? So do you want to shade toward the 0 or away from the 0?
Away from the 0.
Away. So I'm going to shade the inside. Because I don't want to shade the 0. The 0 doesn't work. So shade away from it. Okay, now for these last two parts. The solution set, that's just turning your number line into an inequality. So, you have just one part shaded, right? So when you have one part shaded, you're going to write it as one whole inequality. It's like when we did domain and range in the beginning of the year. we're going to go from -5 less than 1, less than x less than -1. Do you remember this? Less than x less than? All right, so because it's one giant chunk here, we're going to write it as one giant inequality. We're going from -5 to -1. So -5 less than x less than -1. And that's your solution set. And then is -4 a solution? Yes. Because -4 is right here, and that is in my shaded area. Right.
Wait, is Jordan gonna be here tomorrow?
No, I don't know who's coming tomorrow.
Can it be a math teacher? Hopefully it's a good
I don't know who it is.
I like Tommy.
I'll bring in a math teacher.
Yeah, I want a math teacher.
She doesn't have control.
Yeah, I don't know. All right, number 7.
Better get a math.
You can reverse it.
You can. There, I don't know if there is a math teacher sub.
But like we had this one sub and she was just like,
Oh yeah, that one lady with the glasses. And
That
shit.
white lady.
Oh, she was so.
I don't know.
Well, I'm not
she
here.
was funny though. I ain't gonna say
She was
it.
rude.
All right, number 7. So
I literally like had to pass on my college.
number 7 is already everything's already on one side. It already equals 0. So I want two numbers that multiply to give you -12, but add to give you -1.
11-1.
Think about the multiples of 12.
-1 and
-4 and 3.
You really can't do this.
If you need to, come off to the side and think of all your factors. 1 and 12, 2 and 6, 3 and 4. So which one of these is going to give you 1? Well, 3 minus 4. All right, so,
That like what takes up most of my time when I do.
yep. X minus 4, x plus 3. So where are my solutions going to be at?
X equals +4.
4 and -3.
I was gonna say
On my number line, which number goes first?
-3.
-3. Are they open circles or closed circles?
Open.
No, they're closed.
Why is closed?
Because
Because it has a line on the bottom. God.
Yes, closed because it has a line underneath. All right, so for my test point, what am I going to use? 0. Where is 0 on my number line? In between right here. So I'm going to plug 0 in here. 0 squared minus 0 minus 12 is less than or equal to 0. So what's 0 squared minus 0? What's 0 minus 12? Is -12 less than 0?
Yes.
Yes. So my test point works, so I'm going to shade where my 0 is. All right, once again, we have that chunk there, right? The chunk in the middle. So how would you write your solution set? -3. Less than, and we're going to have or equals to because we have the closed. X, and then what comes next? Less than or equal to, and then 4. So less than or equal to x, less than or equal to, that stays the same.
Wait, so are we ever going to shade on the outside of the numbers?
Yeah, I think these next two are outside.
Are you going to do this?
Mhm.
Did you say no?
Yes, I'm going to do them.
I thought you said no. So.
Is 5 a solution?
No.
No, 5's over here. No, not a solution. I'm doing the whole paper, don't worry. I'm going to do the whole paper. All right, go to number 6. All right, number 6. Everything is to one side, so I'm going to try to factor. Now, this one, you might look at it and you're like, ooh, shoot, I don't know how to factor that.
Oh, put -2 on the top and 14 on the bottom.
No.
I thought.
What does it have?
A negative.
Has A and B.
But it got to
Yeah, you can take a -2x out. What's that called?
Subtract.
Simplify.
Starts with a G.
Multiplication.
Some of you said it. Greatest common factor.
I said that.
Okay. Greatest common factor.
Oh my god.
So when you get stuck factoring, a lot of times it's because it has a greatest common factor. Both of these numbers can be divided by 2, and both of these terms have an x with them. We take the negative out because we never like x squared to be negative. So negative 2 divided by negative 2 is 1. X squared, when you take an x out, you just have a plain old x. 14 divided by negative 2, negative 7, and we took the x out, so we don't have that anymore. Yep. Now, anything with an x is going to give you a solution. So, negative 2x equals 0, and x minus 7 equals 0. They will both give you a solution. So, anything with an x is going to have a solution. How would you solve for x on this one? Divide by negative 2, 0. And then what about over here? X equals 7. On your number line, which one comes first? 0. Are they open or closed? Closed, because you have the line underneath. Alright, so are we good so far? Alright, can I use 0 as a test point?
No.
No, because it's one of my solutions. So what's the next best thing?
1.
Well, I would use 1. I mean, you can use 7, but it'd be a big number. I would use 1.
Why not 0?
Because it's one of our
solutions.
solutions.
Mister,
Huh?
why not like 3 or 4?
You start getting bigger, like, because then you have to do 3 squared, which is 9. 9 times negative 2. 14 times 3. It just starts getting bigger. So 0 and 1 keep the numbers nice and small.
Okay.
I'm plugging it back into the original.
What if you can't use 0 or 1?
You use 2.
Are you gonna do that?
I don't know.
Don't do that.
Do it like for extra credit, like use 12 or something.
Okay.
Just do like 4.
Alright, so I plugged in my 1 back into my original. So what's 1 squared? 1 times negative 2? Okay, what's 14 times 1?
14.
Alright, what's negative 2 plus 14?
12.
Is 12 less than or equal to 0?
No.
No. So, oh, and I forgot 1 is right here, right? Alright, so no, 1 doesn't work, so where are you shading?
Outside.
Outside, away from the 1. Alright, so we're shading outside. Alright, when you are shading outside, we're going to have 2 separate inequalities. Because we have 2 separate arrows. Right? So we have 2 separate inequalities. I have 0 and I have 7. Now I just need to figure out where my signs go. And so I don't know if you remember when we did the inequalities before, you can always look at which way your arrows go to help you.
So x is less than 0.
So we're using the values that are smaller than 0. So we have less than or equal to, because it's colored in, which is also the same way that your arrow goes. Right? You see arrow, arrow. Right? And then for the 7, we're using the numbers bigger than 7, so it's going to be greater than or equal to, which is also the way your arrow goes. Yes.
This is easier than
And then is 1 a solution?
No.
No. All right, number 8. All right, what's the first step on number 8?
Move the 25 to the other side.
Move the 25. Very good, Daisy. X squared minus 25 is greater than 0. Okay, so now I want to factor this. What is this called? Anybody remember? Starts with a D.
Denominator.
It's 3 words.
Oh, 3 words?
Think about when we factored. It was also on the bonus question on the test that we took.
D's common denominator.
Yeah. Do you want me? It's 3 words.
Okay, give us the middle word.
Of
Give us the last one.
squares.
Decimals of squares? No.
Distribution.
Differences of squares.
Difference of squares. Yes, difference of squares.
I'm on fire today.
All right, difference of squares. Because x squared and 25, they're both perfect squares.
Yeah, so.
What times what gives you x squared? What times what gives you x squared? X. Now what times what gives you 25?
5.
5.
Plus or minus?
1 is plus, 1 is minus.
Why do that?
X plus a minus.
Oh, so it's a perfect square.
Sorry, I didn't.
Okay, well, plus or minus.
All right, so what are my two solutions?
0. No.
5 and negative 5.
5 and negative 5.
X equals 5. I swear, yeah.
Which one goes first on your number line?
Negative 5.
Open circle or closed circle?
Open.
7.
Open, open. All right, now what number do
In
I...
the middle.
0, which is in the middle. All right, so we're going to use 0 here. 0 squared is greater than 25. What's 0 squared?
0.
Is 0 greater than 25?
No.
No, so we have to shade away.
Man, I'm not paying attention to
It's okay. Your 10th grade show.
All right, so I'll have two separate arrows, right? Two separate arrows, so you're going to have two separate inequalities. X something negative 5 and x something 5. So, is my arrow going less than negative 5 or greater than?
Less than.
Less than. Is it equal to?
No.
No, because there's no line in the beginning.
Right. No line in the beginning, no closed circle, so don't put the line there. And then for the 5, are we using the values bigger than 5? Greater. And is negative 2 a solution?
Wait, what is X?
No.
Yeah.
There you
Oh,
go.
yeah, it is.
Negative 2's right here?
Where's X
Ah.
at? This?
No, that's not the solution.
No. What do you mean where's x at?
Like,
These x's?
yeah.
You put them in there. That's how you answer the question. On here?
Yeah.
They're not on there.
Coordinating.
Like this whole number line is x. Like these are x values, all the numbers. And so both of these are just ways you can write your answer. All right, flip it over. We're going to do the front, which is the graphing. So we're doing the same thing. All right, same except we're going to be using the graph to interpret it. All right, so same thing. So instead of using the number line, we're going to use a graph. Now, we're not graphing a function. Like we're not going to graph like on the calculator. You can't graph the function. All right, but we're going to be using the graph to determine our solution set, which is kind of what's throwing people, I think. All right. So on number 1, we are going to graph this quadratic just like we normally would. And we'll ignore the less than 0 for right now. So we're going to graph the quadratic just like normal. No, by hand. All right, where is your vertex at? You don't remember?
Plus 1. No,
That's 1. What's the x?
Negative 2.
Close. 2. Why is it a positive 2?
Because the number's
Inside nothing.
Yeah. So, vertex, are those two numbers there? Inside changes sign. What's the a value?
Negative 1 over 4.
Very good. All right, so over here we're going to graph 2, 1, down 1, over 4, down 1, over 4.
Wait.
How'd you do that?
Oh, wait, never mind.
Vertex, down 1, over 4. From the vertex, down 1, over 4.
Oh, that's from the birthday.
That'd be hard, right?
All right, so we good on the graphing, right? All right, looking back up here. I want it when you are less than 0. Right? Less than 0. So, on your graph, less than 0 means negative, right? From your x-intercepts, those are the points that we're going to be needing, because x-intercepts are the solutions, right? Which is the solutions what you found on the back, right? So from the x-intercepts, are you less than 0 down this way or up this way?
Down this way.
Down, because that's where it's negative. So these guys here are my solutions.
Didn't we do something like this before?
No,
I don't think so. I don't know.
no, never.
All right, and so now we just need to write the solution set. So this point here is at -2. 1, 2, 3, 4, 5, 6. Okay, this point here is at 6. So those are my two solutions, -2 and 6, because those are the x-intercepts. Do you have two separate arrows, or do you have one giant one?
Separate.
Two separate. Two separate. One here, one here. You got two separate ones. So because you have two separate ones, you are going to have two separate inequalities, just like on the back. X is something -2. X is something 6.
Can it work the same way with the arrows on this one?
Yep.
X is less than 2 and greater than 3.
Less than 2, greater than 6. Very good. So we're using the values less than 2 because we are going this way to the left. We are using the values bigger than 6 because we're going this way to the right. So yeah, the arrows work the same thing here.
I get it with you, but I feel like as soon as you start on
Here's your solution set. Okay, one last question is x equals 2 a solution. So x equals 2 is right here. Is that in your solution set?
No.
No. So it's kind of the same thing. You're just you're using a whole graph instead of just a number line. All right.
Let me try to do number 2 by ourselves.
Let me do one more, and then I'll let you do number 4 yourself.
No, number more.
Okay. How about I do 4 and then you do 3?
No, do 2.
Which one do I want to do? Hold on.
I don't know how to do this. Sorry.
I'm down to do any.
No, I'm gonna do 3. I'm gonna do 3.
Okay.
All right. So what's the first thing you want to do on number 3?
Get it out to one side plus 10.
Very good. Move the 10.
Oh.
X squared minus 7x plus 10 less than or equal to 0. All right. Two numbers multiply to give you 10, add to give you -7.
2 and 5.
2 and 5, and they're going to be negative because we want to get a -7. All right, x minus 2, x minus 5.
X equals plus 2 and X equals plus 4.
Very good. So 2 and 5. All right, so I actually don't care where the vertex is because the x-intercepts are all I need. The reason on number 1 where I found the vertex is because it was written in vertex form. And so that's why I solved these differently. But once again, I don't actually care where the vertex is. I do need to know whether it's a happy face or a sad face, though.
I forgot how to determine that.
Is the x squared positive or negative?
Positive.
So is it happy or sad?
Happy.
Happy. So positive is happy.
I get it because I make that one joke.
All right, and then look where your inequality is with the 0. So I want to know when it is less than or equal to 0. So looking at my graph, do I want the part of it that's below the x-axis or above if I want it to be less than 0? Below, because I want it to be negative. So I want this chunk right here. Does that make sense? All right. That chunk, is that two separate parts or one whole part?
One whole part.
One whole part. So your inequality is going to have the less than or equal to x, less than or equal to, and my two numbers are going to go on either side. 2 and 5. 2 to 5, because you're going from 2 to 5.
Oh, wait, so how do you know that you only were going to use the one underneath the line, the part you circled?
Because it's less than 0. So if it's less than 0, that means negative, right? And so you want the negative numbers, the part that's below. So less than is below, greater than is above. Is 6 a solution?
No.
No. Okay. Let me do number 4 and then I'll let you do number 2, I promise. Alright, number 4, what is that called? No, what's this called, factoring wise?
Oh, you're gonna do what you did on, hold on.
Yeah, it's the one that starts with a D. Difference of squares. So,
How do you know when you're gonna do that?
everything's a square and there's a minus sign. Difference of squares.
It's gonna be x and x, right?
X and X.
And then 2 and 2.
Very good. 2 and 2.
Plus 10.
1 is plus, 1 is minus.
Oh yeah, and then after that, hold on. You're gonna do that.
X equals
X
negative
equals,
2.
yeah.
Good. So X equals negative 2 and 2. So I have negative 2 and 2. Do I have a happy face or a sad face?
Happy.
Happy
Because
face.
X is positive.
Because X is positive. Alright, now looking at my inequality here. It is greater than 0.
So you want above the positive part.
Very good. So you want above. So I want the parts that are above. So am I going to have one big inequality or 2 separate ones?
2 separate ones.
2 separate ones. X, X. What's the number is going to be?
Negative 2 and 2.
Negative 2 and 2. Alright, so this part, is it going to be a less than or a greater than sign?
Greater than.
Less than.
Less than, because you're using the numbers that are, yeah, less than. And then the 2, we're using the numbers that are
This way.
greater than.
This way. That way. We don't get this. We don't get this.
Alright, negative 3, is that a solution?
No.
What? Are you sure?
Wait, hold on.
Yes. Oh,
Who said no? Yes.
Negative 3 is right here, right? So, yes, that's a solution.
I get it.